So in this video we are going to discuss about single particle motion in plasma, case 2. Okay, case 2. We have already discussed case 1, so today we are going to discuss case 2. In this case we will apply both magnetic and electric field. Okay, in the first case we have applied only magnetic field, that is B, along z direction. Z direction means it is out of the, this is the origin, out of the screen, you can say. Okay, it is perpendicular to the screen and its direction is outward. Okay, that means it is facing towards you. Okay, so it is coming out of the screen, you can imagine like that. Okay, so this is magnetic field. So here we are going to apply electric field also in the plane xz. Okay, in the plane xz. Okay, but before we discuss this case, let me remind you the first case. In the first case we had taken magnetic field along z direction and electric field, no external electric field was applied in the first case, and we have also got that the v dot x, that is equal to qb by m vy. Then we also got that vy dot, that is equal to minus qb by m vx, and we had got that vz is equal to constant. Okay, and we had also got vz is equal to constant. And solving these two, we had got this equation also. You should remember that x minus x naught minus I v perpendicular omega c e into I e to the power I omega t, and we had also got that y minus y naught is equal to this one plus minus v perpendicular omega c e I omega c t. Okay, those equations we have we had already obtained in case 1. Okay, in case 1. Okay, and these two satisfies this equation, that is x minus x naught whole square plus y minus y naught whole square is equal to r l square. Okay, which is an equation of a circle, and of radius rl, which is known as Larmor radius. Okay, so this means, suppose this is a positive charge moving with velocity v, so it will its motion will be like this circular. And as I have not discussed this point in the first case, okay, so before you watch this video you must watch the lecture 4, fourth lecture, that means last video that I have uploaded. Okay, so please go through that, then what's this, then you will understand. Okay, then we had got that vz is equal to constant, so that means this charge, positive charge, will move in this circular part. Also it will have motion, its center will move towards z axis, it is coming out of the screen like this. Okay, so like this it will, and this type of motion is called helical motion. Okay, this motion is called helical motion. Now in this case, let us suppose this is in positive charge with velocity v, and here let us apply a magnetic field b is equal to bz cap. We have applied the magnetic field along z axis. Okay, so B field is along Z axis. Okay, so assume that Z axis is coming out of the screen perpendicularly, okay, towards you, suppose. So it is perpendicular to the screen of your device, and you can consider it is coming outward, okay, towards your face. Okay, so now, so in the first case, there was no external field, but now we are going to apply an external in the first case there was no external electric field. Now we are going to apply an electric field. Okay, so let us also apply E field in xy plane. Okay, so that will be equal to, so if we apply an electric field in this along in xy plane, in this plane, sorry, not xy plane, sorry, along xz plane, not xy, it should be xz. Okay, along xz plane. So in the xz plane, so then in this plane, okay, so this is the xz plane, and here is the electric field. In this way we have applied. Okay, so there will be x component, okay, ex x cap plus ez into z cap, okay, and y component is 0. Okay, ey is 0. Okay, because this electric field is applied in the xz plane. Okay, in the xz plane. Okay, now what will happen, you see, now let us study the motion of this particle due to these two fields, magnetic field and electric field. So here the particle will have two motions here. Okay, what are the two motions? Circular Larmor gyration and a drift of guiding center. Okay, so let us study this mathematically. Okay, so here you see force acting on this particle, positive particle, due to these two fields is given by F Q V cross B plus E. Okay, so this will be the force acting on the particle. Okay, so here F also is given by mv dot, time derivative of velocity. Okay, then Q V cross B, okay, plus magnetic field. So why F is equal to mv dot? Because you see, we know F equal to ma. A means acceleration. Acceleration is nothing but time derivative of velocity v. ddt of v means we can write v dot. Okay, so hope you have understood this. Okay, now from here what we can do, this v dot will have three components. We can write like this: m vx dot x cap plus vy dot y cap plus vz dot z cap is equal to, so here we can find, so here let me clean this part. here you see this part V cross B. How to find it? So X component, Y component, Z component. So X, Y, Z. So components of V are Vx, Vy, Vz, and common components of magnetic field along X and Y 0, and the Z component is B. Okay, so from here we can find Q, B, Vy, X cap. So how to simplify this I have already shown in the first case. So next Q. So hope you have understood this, how to simplify this. Plus Q. Here in this case there will be three components in electric field also. So where Y component is 0, so we will get Q Ex X cap plus Q Ez Z cap. Okay, and one more thing, the Z component of V cross B here, so it will be Z cap into Vx into 0 minus 0 into Vy. So this part will be 0, that's why Q into 0 is 0. So that's why I have not written this term here. So hope you have understood. Now take a screenshot, or you may note it. Okay, so let's scroll up the page. Okay, now you see, if you compare the X components on both sides and Y components and Z components, if you compare each components on the both side, then you will get M Vx dot is equal to Q Vy B plus Q Ex. Okay, this is equation number 1. So how we have got this? We have compared the X component on left hand side with the X component on the right hand side. Similarly, we can compare the Y component with the Y component of right hand side. Okay, similarly Z also. So here you see X components on the left hand side is M V dot X, here Q B V Y and Q E X. Okay, these are X components. So from this X components we have got the first equation. Then similarly, comparing the Y components, we will get M V Y dot is equal to minus Q V X B. This is equation number 2, and M V dot Z is equal to Q E X. Okay, this is equation number 3. So this is what we have got. Okay, so now equation number 3 implies V dot Z is equal to Q by M E X. Okay, sorry, not E X, that should be E Z. Okay, this component should be E Z. Okay, this is E Z. Okay, so here you see, if you take if you integrate both side, integrating both side, then we will get Vz. After integration, V dot Z will become Vz, and we will get Q Ez by m t plus vz0. This is equation number 4, where vz naught is integrating constant. Okay, so now you see, so where this t come from, let me explain in details. V dot z is equal to q by m ez. That means dt of vz q by m ez, which can be written as dvz is equal to q by m ez dt. Okay, now if you integrate both sides, then integration of dt is t. Okay, that's how we have got a t. Okay, hope you have understood this. So now here you see, let us take the equation number 1 first again. Okay, from equation number 1 we will get vx dot is equal to qb by m vy plus q by m ex. So we have simplified this equation, dividing both side by m. We have got this. Okay, so now you see, we know that cyclotron frequency omega c, that is equal to plus minus qb by m. Okay, so we can replace this term qb by m by plus minus wc. Okay, so let me scroll up a little bit. Okay, so we will get v dot x is equal to so let me write this term first, q by m ex, then let us replace this by plus minus wc, because wc, sorry, not wc, it is omega c, cyclotron frequency, is plus minus q by b, sorry, qb by m. So that's why qb by m can be written as plus minus, will be replaced by plus minus omega c. So here qb by m into vy, so here we have to write vy. Okay, so hope you have understood this. This is one another from equation number 2. From equation number 2, so what we will get from equation number 2, we will get vy dot is equal to minus qb by m vx is equal to minus plus omega c vx. We will get this. Okay, now you see, we know qb by m, we can write plus minus omega c. So if you have q minus qb b minus qb by m, then if you replace the qb by m by plus minus omega c, then it becomes minus plus omega c. Remember that. Okay, because you see, when you will multiply this minus with plus, then it will be minus. When you multiply this minus with the minus, it becomes plus. Okay, hope you got it. So now let us consider this pair of equations, as equation number 5. Okay, I have taken this as equation number 5. Okay, now let us differentiate this equation number 1. Okay, so let me write this one here. If you differentiate equation number 1, okay, so let us write differentiating equation number 1. So equation number 1, what was the equation number 1? Equation number 1 was m vx dot is equal to q y, sorry, vy, not y, vy b plus q ex. Okay, this was equation number 1. If you differentiate this, then you will get m vx double dot is equal to q y dot. So here we are differentiating with respect to time. Okay, so remember that differentiating equation number 1 with respect to time. B plus q ex, this part will be 0 because q ex, this is constant, so differentiating this we will get 0. Okay, so we will have this one only. Then we can write v double dot is equal to q b by m y double dot. Okay, sorry, not double dot, single dot, y dot. So that's what we have got. Okay, now you see, from the equation number 2, what was equation number 2? If you check this equation number 2, so equation number 2 was m y dot is equal to minus q vx b. This is equation number 2, isn't it? So from here you see, we can write y dot is equal to minus qb by m minus qb by m vx. Okay, minus qb by m vx, we can write like that. Okay, so here you see, we already got that b double dot x and is equal to, this qb by m can be replaced by plus minus omega c b dot y. Then you see, v dot y is equal to minus q by m, which again minus q by m, qb by m, this can be replaced by plus minus omega c into vx, so which is going to be equal to minus plus omega c vx. Now you can replace this v dot by this term here in this equation. Then doing so, we will get v double dot x plus minus omega c into minus plus omega c vx. We will get this. Then if you multiply these two, we will get v double dot x minus omega c square vx. Okay, we're gonna have this. This is suppose equation number 6. This is equation number 6. Okay, so hope you have understood this, how we have got this one. Now let us find v double dot y. Okay, so before that one question may come to your mind, that product of these two, why it is minus omega c square. Okay, let me explain. So plus minus omega c into minus plus omega c, what does it mean? That means when you take this plus omega c, you have to multiply with minus omega c, that's gonna be minus omega c square. If you take this as negative, then it must be positive, then also it is minus. So hope you have got this. Okay, now let us find vy double dot. So how to obtain this? This can be obtained by differentiating this equation number 5. Okay, yeah, so we can, if we differentiate this equation, vy dot is equal to minus plus omega c vx. If you differentiate this equation, then you will get v double dot y, sorry, vy double dot minus plus omega c vx dot. Okay, vx dot. Now we can replace the Vx dot. Okay, so by what? We can replace the Vx dot by this equation. Vx dot is equal to q by m ex plus minus omega c vy. This equation, this one. Okay, so let us replace the Vx dot by this equation. Okay, then we will get qym ex plus minus omega c vy. Okay, vy. Now you see, we know that plus minus omega c is equal to qb by m. Okay, so we can write q by m is equal to plus minus omega c by b. Okay, so that's why this q by m can be replaced by this. Okay, let us do it. So we can write vy double dot minus plus omega c plus minus omega c ex by b plus minus omega c vy. Okay, now if you multiply this two terms, then we will get minus omega c square. So ex b plus vy. So that means we have taken plus minus omega c common, then we have multiplied with minus plus omega c. So we have got vy double dot, equation number, this is suppose 7. This is equation number 7. So hope you have understood this. Okay, now this equation number 7, here you see this term, differentiation of this term ex by b is equal to 0 as it is constant. Okay, so here you see, and that's why this equation number 7 also can be written as, here double dot means double differentiation, second order differentiation. So we can write like this, vy. Also along with this we can write ex by b because its differentiation is 0. Okay, so here it will be equal to minus omega c square ex by b plus vy. Okay, this is suppose equation number 8. Now here you say, let me keep these equations, equation number 6 and equation number 8. Let me clean the remaining parts. Okay, so in the first case we also had got these two equations, vx double dot is equal to minus q b by m whole square vy, which can be written as minus omega c square, where omega c is cyclotron frequency vy. And also we had got vy double dot minus qb by m square y dot. Okay, and here this one also can be written as minus omega c square vy. Okay, so we had got these two equations, and those are what? Nothing but equations of simple harmonic motion. So that's why we had taken the solutions of this equation as, so here this equation and this equation same, exactly same, so we can take solution of equation number 6. Okay, simple harmonic motion. So equation number 6, its solution can be written as vx v perpendicular e to the power I omega c t This is suppose equation number 9. So what does V perpendicular mean? So that is already I have explained in the first. And solution of this equation we had got Vy is equal to plus minus IV perpendicular e to the power I omega c t. Now you see, if you compare this equation with this one, so these two are similar type of equations, okay, but here we have got one extra term, that is ex by b, okay, which is not here in this equation, okay. So if the solution of this equation is this one, then solution of this equation will be what? It's just like this. Let me show you the solution. If you compare these two equations, this one and this one, sorry, this one, this equation with this one, okay, if you compare these two equations, and then as we know the solution of this equation is this one, and comparing these two we can obtain this solution of equation number 8 as well, and that will be nothing but solution of equation number 7 will be, sorry, not 7, that's 8, okay, will be Vy equal to plus minus I V perpendicular e to the power I omega c t. The extra term should be written ex by b, okay. So this is the solution of equation number 8, okay. So you see, let me explain it again. So here you see, so you can see this equation and equation number 8, this one, they're in the same form, but we have extra term here ex by b, isn't it? So in the solution of this equation also we have to write the extra term minus ex by b here, okay. So here you see, this can be written as this Vx also can be written as x dot, time differentiation of x displacement, that is velocity, so it can be written as x dot. So let me write this one as equation number 9, and this one can be written as y dot, okay. So let me consider both of these two equations as equation number 9, this pair of equations taken as equation number 9, okay. So now what to do? Now let us integrate them one by one, okay, then we will take the real part, okay. So let me clean this page and let me keep only this equation number 9 now, okay. So let us integrate this one first. Integrating from x naught to x, so we will get here dx is equal to v perpendicular e to the power I omega c t dt, okay. So how we have got this equation? Now you see, if x dot is equal to, from this equation, if x dot is equal to v perpendicular e to the power I omega c t, x dot means dx dt, okay. So we can write like this. So it implies dx is equal to v perpendicular e I omega c t and dt, okay. So now if you integrate, then we will get x minus x naught. So actually integration of dx is x, so if you put limit x naught to x, then we will get x minus x naught, that's equal to v perpendicular e to the power I omega ct by I omega c, okay. Now here you see, if you multiply I here and here, then we will get minus I v perpendicular e to the power I omega ct by omega c. Okay, because you see I into I minus 1. Okay, and there is also one I, so we can write minus I here. Okay, hope you have understood this. So let me clean it. Okay, so then here you see v perpendicular by omega c, v perpendicular by omega c, this gives Larmor radius RL. Okay, this gives Larmor radius RL. So we can replace this term by RL. So doing so, we will get I RL e to the power I omega ct. Okay, and e to the power I omega ct means here minus I RL. Sorry. So let me scroll up a bit. So here minus I RL e to the power I omega ct. Instead of e to the power I omega ct, we can write cos omega ct plus I sin omega ct, because we know that e to the power I theta is equal to cos theta plus I sin theta. Okay, using that identity we have got this. Okay, so if we take the real parts, so here we need to take the real parts only, not the imaginary. So if you take the real part, here you see, if you multiply this one with this one, then this part will be virtual, imaginary part, and this one with this one, here I will be again minus 1, minus minus positive. Here this one will be real part, product of this one and IRL will be real part. Okay, so here we will get, taking the real part, we will get x minus x naught is equal to RL sine omega ct, sine omega ct. This is equation number 10. Okay, taking only the real parts, the real part. Okay, so now what to do? Let me integrate this one, this equation. Let me integrate this equation. Okay, so if we integrate that equation, then we will get y minus y naught is equal to plus minus I v perpendicular e to the power I omega ct. Okay, so before writing this line directly, let me write this one first. Okay, integration from y naught to y dy is equal to integration plus minus I v perpendicular e I omega ct minus ex by b bracket close dt. Okay, so now if we integrate, then we will get y minus y naught is equal to plus minus I v perpendicular e I omega ct by I omega c, then minus ex b t. Okay, so again replace the v perpendicular by omega c by RL, that is Larmor radius, plus minus RL e to the power I omega ct minus ext by b. Okay, so now here also this can be replaced by e to the power I omega ct it can be replaced by cos omega ct plus I sin omega ct. Now let us take the real part only. Okay, if you have here plus minus rl only, if there is no I in this part, then we will get here rl plus minus, okay, into this. Then this part will be the real part here in this case. So we will have plus minus rl cos omega ct minus ex t by b. This is equation number 10. Sorry, not 10, in this case 11. It should be 11. Okay, this is y minus y naught. Okay, so here you see, so let me keep these two equations only. Let me clean this page. Okay, so in case 1, so when electric field was not applied, then we had got x minus x naught is equal to rl sin omega ct, and y minus y naught we had got plus minus rl cos omega ct. Here these two equations are similar. These two equations are similar to these two. Okay, but here we have additional term, one additional term here. This is ext by b. So here ex by b is called, is the electric field, is the electric field drift, or we can say E cross B drift. Okay, and as you can see, if you compare this, so we had got in first case that this particle, it is x-axis, this is y, and z-axis is coming out of the screen, if you consider like this. Okay, then this is the magnetic field, then it was moving like this. Okay, also because of this constant velocity bz equal to constant, so it will take it will move like this, coming out of the screen. Okay, it is helical motion. Okay, and here you see, if you consider this particle and this is the center, suppose this is the guiding center. Okay, because of this drift we will get there will be a drift of this guiding center towards the negative y-axis. Okay, towards the negative y-axis. Okay, so the resulting motion will be like this. Let me draw it again. Okay, so suppose this is the x-axis, this is y, this is y dash, that means the negative y-axis, and this is x dash 0 here, and this is the z, which is coming outward, coming out from the screen. So this is the positive surge. So here you see its motion will be in this direction, like this. Okay, so here you see the from these two equations, the lower motion, as in the first case, it will be in the same direction, but there will be a drift of this center towards negative y-axis. Okay, because of that, direction of motion will be like this. Okay, between these two axes, negative y-axis and z. Okay, so in this direction we will get the, yes, in this direction the particle will move. Okay, so that's why we can write, so let me clean this part. Okay, equation 9 and 10, sorry, not 9 and 10, 10 and 11, 10 and 11 describe the Larmor motion but there is a superimposed drift Vg, that means drift velocity of guiding center. This is the drift velocity of the guiding center in negative y direction. Okay, negative y direction. So let us compare the case 1 and case 2. Okay, so let me draw the pictures for case 1 and case 2. So here this is x, this is y, this is negative y, here it is z, it is coming out of the screen. Okay, this is y, this is x, this is y. Okay, now this is the first case. Here the motion was like this. This is helical motion. Here all the circles are same. Okay, but in this case this is positive surge and the direction of the motion will be like this. Okay, because here you see we had in the first case we had applied only the magnetic field, case 1. Okay, this is case 1, and here we have applied magnetic field in z direction, as well as we have applied an electric field on electric field in xz plane. Okay, electric field in xz plane in this way. Okay, so in absence of this electric field, the motion was supposed to be like this. Okay, but due to presence of this electric field, there will be a drift of the guiding center towards the negative y-axis. Okay, negative y-axis. Okay, so that's why the motion, direction of the motion between the z-axis and negative y-axis. Okay, so the guiding center is drifting down the negative y-axis. So hope you have understood. This is case 2. Okay, so this is the comparison of case 1 and case 2. Okay, so now let me find the general formula for Vc. Okay, that means Vc means drift velocity of the guiding center, because this guiding center is drifting towards the negative y-axis. So let me find the guiding center velocity of this drift velocity of the guiding center. Before we obtain the formula of drift velocity of guiding center, let me explain this motion again. Here you see in this direction this is the electric field and this is the magnetic field. It is coming out of the screen, you may imagine like it. Okay, it is coming out of the screen. Here you see this is the positive charge when it is moving like this. Okay, then this first half cycle, so when it is moving like this, because of this electric field it gains energy and the radius, the Larmor radius increases, and when it comes like this in the second half cycle it loses energy. So it's in this case this Larmor radius decreases again. Along this direction it will its energy will be increased, and then again in this direction energy will be decreased. That's why here you see first half cycle on the right hand side Larmor radius increases, and on the left hand side it decreases. Okay, Larmor radius decreases. Okay, so similarly if it is an electron instead of ion, if it is an electron, negatively charged electron, so it will move like this. Okay, in this direction. Here it is in this direction, it is moving like this. Okay, anti-clockwise, and this this is clockwise, not anti-clockwise. Here it is anti-clockwise. Okay, so here you see it is its Larmor motion is along z-axis, and the guiding center is drifting down along negative y-axis, this one. Okay, when the here you see this is the z-axis, this is x, this is y. In the first case, in case 1, there was no external electric field, only magnetic field was there. In that case only there was Larmor motion. Okay, and here each cycle radius in each cycle were was same, but here not same. Okay, here in half cycle it is increasing, in next half cycle it is decreasing. Okay, so I hope you have understood this. Now let's find the expression for. So let me obtain the expression for VGC. Okay, so let us take the equation of motion again. M dv dt is equal to q e plus q v cross b. Okay, this was the equation of motion. Here you see this term on the left hand side, it represents the circular motion only. Okay, so it doesn't represent the motion due to this electric field. It doesn't represent the motion of guiding center, drift of guiding center. Okay, that's why we can write this side as 0. Okay, so q e vector plus v vector into b. That's how we can write e plus v cross b is equal to 0. So here let me write one thing. Since m dv dt represents only circular motion, so let us omit m dv by dt. Okay, so doing so we have got this equation. Then here you see this e vector we can write equal to minus v cross b. Okay, v cross b. So then again, so if we multiply here b vector e cross b and minus v cross b cross b. Okay, so let us apply the law of vector triple product. Then we will get b dot product b minus b b dot product v. Now here you see this b dot v will be equal to 0. Why? Now let me explain. So we have applied the magnetic field along z axis, okay, and drifting of the guiding center is towards negative y axis, okay, like this. So the direction of drifting is perpendicular to the magnetic field, so that's why this must be equal to 0. So we have got now E cross B is equal to V. So this is B square, and it implies V vector B is equal to E cross B by V square, and this is nothing but the drift velocity of the guiding center. So this is the expression of drift velocity of guiding center. Okay, so hope you have understood this, and if you liked my video then subscribe my channel. Thank you.